In and around and known ANJEC for many years. I want to take a second and provide special recognition to ANJEC staff, many of whom have been with us for a decade or more, and we have a few new faces on board as well. So I know some of them are still working really hard out in the main room, but if you're with ANJEC staff, can I have you stand up for a second? We've got one, two, we've got a few who are already standing who just walked in the door, so thank you. ANJEC staff are some of the hardest working staff I've ever had the privilege to work with. They are masters of many issues. They are grace under pressure, and I am privileged to work with them. So could I just ask all the EC members to stand up for a second? We should have most of the room standing up. You guys are rock stars because you're the ones doing work on the ground, protecting and restoring our natural environment. Every day. One of the great things about this conference is that we have opportunity to network with one another because it can feel lonely sometimes at night meetings at 7, 8 o'clock at night, and you may feel like you're the only one. You're not. ANJEC is here as a resource provider. We are here to answer your questions, whether it is strategy. We are here for therapy, to vent if you've got a particularly tough night ahead of you or behind you. We have resources such as wheels and Plinko games to bring to your community events. We have ANJEC Report, ANJEC News. We post ongoing news from the state and local community on our Facebook and Twitter feed. So for those of you scrolling around on your phones, if you haven't liked us yet on Facebook or followed us on Twitter at ANJEC Tweets, we would love you to follow us. So that's a little bit about what ANJEC is and what we do. Our mission is to protect and restore New Jersey's natural resources by educating, empowering, and inspiring all of you, all of the environmental commissioners, to then go out and work on the local level. So that's why you guys are the real rock stars. I want to talk a little bit about some of the initiatives that ANJEC is working on proactively. So in addition to providing resources and therapy and education, some of the proactive agendas that ANJEC is pursuing right now is protection and restoration of the Delaware River watershed. We are in the Delaware River watershed right now. So all of the rain that's coming down today will eventually flow to the Delaware River. The two primary areas that ANJEC is focusing on are the New Jersey Highlands and the South Jersey Bayshore and Pinelands, known as the Kirkwood-Cohansey Aquifer. These two areas provide the majority of drinking water resources to New Jersey. However, it's bigger than just us. This is a 4-state initiative: New York, New Jersey, Pennsylvania, and Delaware. This work is primarily funded and supported by the William Penn Foundation in Philadelphia. We are grateful for their support, and we are grateful for the many, many environmental commissioners who are doing work on the ground. Everything from education about septic system maintenance to constructing rain gardens. I see Cheryl Reardon sneaking in right now. She's leading multiple rain garden construction projects in South Jersey right now. And those EC members in the audience are leading up those projects, and ANJEC is providing support. We are also working to provide support to our cities. So in New Jersey, how many people have heard of a CSO, Combined Sewer Overflow? Excellent, I love this crowd. So we know the issues that when our treatment works facilities, when we flush the toilet, when we run the shower, and they become overwhelmed with too much rain, we have raw, untreated sewage directly discharging into our waterways and in many cases backing up into our streets like it does in Newark. So we are working with environmental commissioners and green teams at Sustainable Jersey, through Jersey Waterworks. There are many universities, NJIT, Rutgers, who are in the audience today, who are also working in partnership with us to begin to do the education component of the permits that are required to address those CSOs and stop raw sewage from flowing into our waterways and our streets. We're also really proud to be working with a number of cities in supporting renewable energy initiatives. So Jersey City was the first. The Environmental Commission started this initiative. They adopted a resolution to secure 80% renewable energy for their city by 2050, and it was endorsed by Mayor Fulop this year, so they're working on it. They are changing their contracts, they're setting new goals, and there are more than a dozen municipalities that have adopted such an ordinance subsequently. So we're happy to work with NJLCV. We're happy to work with Newark, that now has a cumulative impacts ordinance. So did you know on the municipal level that municipalities really cannot do much about air pollution? So in Newark, we have a greater than 75% increase in child asthma rates, which then leads to more days out of school, which puts children behind in their education. So Newark said that that's enough. We want to be able to control what kind of pollution our citizens are ingesting, and so we want to have a say in this. So they're taking a stand, and we're happy to support and work with them. We're also fighting for our oceans. So I'm sure many of us know the Lorax. We've read it to our kids, to our nieces, to our nephews, to our grandkids. So unless someone like you cares a whole awful lot, nothing will change. Well, unless someone like you cares a whole awful lot, plastic waste in the ocean will outweigh fish by 2050. So all of the plastic bag, plastic bottle initiatives that you're working so hard on at the local level, I salute you. I am in honor of you because you are trying to change the way to fix our oceans. We're also supporting the Mid-Atlantic Ocean Plan, which calls for sustainable uses, healthy oceans, conservation zones, and to work on this trash problem. We have grants, or do we have any grant award winners in the room? So we've got a lot of hands, yeah. ANJEC is really proud to have a grants program. We have a small grants program. Since 2002, we've given out $1.5 million. I should say $1.5 million. And we have had environmental commissioners support or construct pollinator gardens for birds and bees, community gardens, rain gardens, trail construction, pull those nasty invasive species out of the water, out of the trails. We are really proud of the work that you're doing, and we're going to work hard to continue to raise money so that we can get money into your hands so that you can do this good work on the ground in your communities. And we're also fighting in Trenton because somebody's got to do it, right? We are proud to work with a number of wonderful environmental groups, many of whom I see here today. We're proud to have a very long list of co-sponsors. If you flip over the back of that program that you have, you see all the nonprofits that we're working with that are here today, that have tables out there. I encourage you to please go visit them, learn about the wonderful work that they're doing on the ground. Most of them are standing side by side with one another in Trenton, fighting really ridiculous rules that are going through, such as the amendments to the flood hazard rules that allow for more development closer to our streams. Because, anybody think that's a good idea? Yeah, this crowd doesn't. It also, there's a provision in there where the state used to have control over utility lines going through flood hazard areas and streams. And they wanted to have a say in that, to oversee and make sure that it was smart development. So now when a pipeline goes through under the revised flood hazard rules, the state said, not it, and they're not reviewing it. So if you want to learn more about that, you should go to our regulatory and legislative update session, and we can tell you more about it. We've got a lot of great sessions today. We're really proud to be here. This is how you get in touch with us. I know all of you know how to get in touch with us. With that, and one time, check that out, I would like to introduce Dr. David Robinson. I am really pleased to have him here this morning. Dr. David Robinson he has an exceptionally cool job. He is New Jersey's state climatologist. Did you know he had a state climatologist? Many of you did. So he earned his doctorate in earth sciences at Columbia University, and he's now stationed at Rutgers. So go Scarlet Knights. His bio is on page 3, and you can check that out. He's on the board of the National Academy of Sciences, a fellow of the American Meteorological Society, has been named NOAA's Environmental Hero, past president of the American Association of State Climatologists. It goes on and on. We are really pleased to have him here. I saw him speak at a prior occasion and found that the way he tells the story of climate change and how it's affecting New Jersey is both engaging and compelling. So with that, I'm very pleased to have Dr. David Robinson with us, and please join me in giving him a warm welcome.
Not too much pressure.
Hi. Let me get you set up here.
not too loud.
Thank you.
Thank you.
Awesome. Grab my water. And there's your remote.
Good morning, everyone. It's a pleasure to be here. I brought my rain gauge with me. Yeah, there's a certain irony in this morning with the rain coming down, and you saw a slide just a minute ago that this county and northward is in a drought watch and has been since July with good reason. Yes, I've had a little bit of an input on some decisions when it's come to that on the national and state level, but I just wanted to congratulate all of you. What a wonderful group. I think I've spoken at half of the sponsors on here today, and I am a proud trustee of the Nature Conservancy, as well as being involved on committee work at Stony Brook Millstone and beyond. So it's a pleasure to see friends out here and introduce the State Climate Office and what we do in a little bit of this presentation to the rest of you. Yes, and I am a neighbor of, well, was a neighbor of Alpine, not Demarest, but I grew up in Tenafly. And lived in Alpine, house sitting as a grad student up at Lamont Observatory for a couple of years, a long time ago. The trees were very short at that point. So it's just a pleasure to be here. Just with, I know I'm preaching to the choir in a sense today, but that's okay because you folks can take the story and bring it to your constituents and learn a little bit more. And know that you're doing important work. So with that being said, you've heard a little bit about the credentials and all. I am in the Department of Geography as a professor at Rutgers. So while some of you are lonely at night doing certain things with your commission, I was lonely grading 43 exams late last night. But it was my fault for giving it yesterday, right? But the last question I have to grade is the student's interpretation of the greenhouse effect. So it's going to be interesting to see those answers. There's plenty to talk about when it comes to the environment of New Jersey, when it talks about the weather and climate of New Jersey. I can only begin to touch on it now. It's so exciting to hear all the awards won and all you do in your towns in the 565. Thanks, Princeton, for making it, not 566. I do teach a course in the geography of New Jersey, which is a lot of fun, but more well beyond the environmental side. And I visited many of the communities, and you will learn we have weather stations in a number of the communities, and we have volunteer observers for precipitation in hundreds of communities around the state. But of course, I'm here to try to get more, to get you guys to get more out there. So anyway, on we go. Greetings from the State Climate Office. I know some of you out here, and many of you have heard of the State Climate Office. If not, that's okay, because we work behind the scenes in many cases. But we're here to help decision makers make decisions. That could be a mom or dad knowing what coat to put on their children in the morning by visiting our weather network. It could be the governor and the emergency management office during Sandy, when 45 of our weather stations were providing them with data around the state every 5 minutes throughout the storm. That was the fewest we had out of our 54 stations operating on that those fateful days back in October, just 4 years ago. So we cover the wide gamut. And our credo as state climatologists is locals trusting locals. That's to take nothing away from the regional climate centers, from NOAA and the National Weather Service. We work hand in hand with those folks as state climatologists, but we can take the bigger picture and get down into the weeds with you and provide you with information so you can make decisions at the community level. So enough said about that, except visit our website. It's njclimate.org. Pretty simple. This is what we're going to cover in the next 45 minutes or so, leaving some time at the end, hopefully, for some questions. Just an overview of what makes New Jersey's weather and climate tick. Then looking at past, present, and future Jersey, and then a little bit on impacts and potential actions. Putting my hat on as a geographer, where we're very much interested in the intersection of humans and their environment and how each acts on the other. although I am not a social scientist. Truth be told, I don't even have a degree in geography, yet I chaired the department for 12 years. But shh, don't tell the dean that. No, I'm a geographer at heart, although I began as geology and earth science, but really consider myself a climatologist, earth system scientist, and geographer, which many of you are, whether you know it or not out there. Climate or weather, it's a fuzzy one. It's a fuzzy one. And for good reason. You can't be a good climatologist without knowing meteorology and vice versa. But weather is generally what's going on today, why it's rained heavily in South Jersey and a foot of rain fell in southern Delaware yesterday and nothing fell up in North Jersey, what's happening this weekend, and whether Hurricane Matthew will pay the East Coast a visit next week, mid to late next week, if it is to happen, and so on and so forth. That's the genre of meteorology, atmospheric science in the short term. Climate's the longer term, but it's not just the average of weather. It is really the foundation of the weather enterprise. It's the background climatology, the averages, the extremes, the variability, the trends. The forces from sun to ocean to land surfaces, as we'll see in a minute with a slide. Another way of thinking about it, climate's your personality, weather's your mood. You may have a very affable personality, but you got stuck in a little bit of traffic on Route 1 this morning when you had to get down here to speak at the meeting, and maybe your mood soured a little bit for a minute or two. But that's one way of thinking about it. That I like to give as something you might take home rather than the long scientific explanation as such. But as I was mentioning, we're talking about all of these players, be it the sun, which drives everything in the weather and climate enterprise, to different land surface types. Notice front and centers, what humans have done to their environment, in terms of urbanization and agriculture, but we've got the oceans, and we've got the lands. We've got the deep ocean, we've got the shallow ocean, we've got different landscapes, we have glaciers, we have volcanoes, and all of these are found, well, directly or indirectly, in New Jersey. We're a bit of a microcosm here. We've got this large water body to our east, this large landmass to our west. We're about halfway from the poles down to the equator. Glaciers and ice sheets? Not today, but 20,000 years ago, and I'll show you a map on that in a minute. And we are very cognizant of what's going on up in the higher latitudes when it has to do with this coastline that we have. I'm very, very much interested in that as an aside. My research is in snow cover globally. Outside of New Jersey, I'm known as a snowman. And I maintain records of snow extent over northern hemisphere land masses going back 50 years with satellites. And it's used globally. I have colleagues who use the data, and I study globally, along with ice sheets and sea ice. So polar climates are my bag when I'm not talking Jersey. I'm not talking Jersey. But it does have direct and indirect effects on life here, and weather and climate here in New Jersey. And then volcanoes. We haven't had volcanoes in New Jersey in about 200 million years. The Watchungs and intrusive rocks of the Palisades with magmatic activity near the surface. But we don't have to be next to a volcano for it to have an impact on our climate. Just have to go back to 1991 when a volcano named Pinatubo. St. Helens, minor climate impacts. It was a lateral eruption, wasn't that big, but Pinatubo erupted in the Philippines. Spread a volcanic veil in our stratosphere above where most weather happens and shaded the Earth, if you will, for a year and a half. And that was the coolest year our planet's experienced since that time. Not just in New Jersey, and it wasn't one of our cooler years in the last several decades, but globally, showing how natural forces can influence the climate. Here in New Jersey, occurring the other side of the Earth. So we have all of these at play here in New Jersey, and making it so interesting to study, from our pinelands and our agricultural lands. These darker areas are urban areas. Really makes for a microcosm of study in Jersey. And what makes it so interesting? What makes our weather vary so much? Well, I call it the squeeze play, and we're experiencing it these couple of days right now. We've got a high pressure system, maritime high pressure system to the north that's helping bring winds in and causing flooding along the coast. We've got a trough of low pressure to our west, which is helping to pump up moisture from the south, and we're squeezed in between, and we've got winds gusting over 40 miles an hour along the coast. We've got heavy rain in South Jersey that's been battling to get north because of the dry high pressure off to our northeast. So a perfect example. I mean, Mother Nature set things up well for this slide today. And it's this constant battle that we're facing here in New Jersey that gives us our seasons, that gives us our seasonality, it gives us our variations from day to day, week to week, and year to year. You can just look back to this summer, and there's a tropical maritime air mass that won out. You may know it, we call it the Bermuda High. And that just won out all summer long, giving us our fourth hottest summer in the last 122 years. But it seemed kind of normal maybe, because 8 of the top 10 warmest summers in the last 120 years have occurred in this century. So we're kind of getting used to it. I talk to my students and say, the summer that you're used to experiencing in New Jersey is different than what your parents experienced and what your grandparents experienced. And you can blame it on the Bermuda High being very, very persnickety and persistent and strong, and other background factors as well. So here we are in this squeeze play. And I guess the take-home point there of that story is, in New Jersey, we import most of our weather. We don't grow much of it, and it's a matter of which import direction is most prevalent that will dictate our seasons. We don't know this winter, to be honest with you. There's no El Nino, there's not going to be a La Nina, little hints we get on what the winter can be. So, the battle zones are set, the players are there, and it's going to be interesting to see. And I can tell you one thing right now, confidence in any long-range forecasting for this winter is miserable, because we don't have strong, and not that it's ever great, but that we don't have any strong signals out there to give us hints this year that we had last winter, for instance. So stay tuned. So that will answer the question that someone's going to ask me today at some point. Looking at this squeeze play, here's a case, really a remarkable case from just 2 Februaries ago, where you have temperatures in the single digits up in the Adirondacks, and it's near 80 down in Norfolk. This is one snapshot in time. And here in New Jersey, it's in the mid-50s in South Jersey, and it's in the low to mid-30s in North Jersey. Snapshot in time. And part of the reason why you have this temperature disparity in New Jersey is the northern half of the state, it's not shown very well, if I can show with this, yeah. The northern half of the state is snow covered. That's not cloud cover, that's snow covered. And there's Round Valley Reservoir, unfrozen. So south of 195 or so, it's snow free. So the sun's energy is being absorbed and heating the ground and heating the atmosphere and warming it up. Up in North Jersey, the sun's reflecting off the snow cover, or the energy is being used to melt the snow, so it's keeping temperatures 20 degrees cooler. So again, that squeeze right here in our state in this particular occasion. And here are the controls. Pick your county. All 21 counties hopefully here today. Pick your community, and you can see where you sit. This is a loosely drawn map of zones within the state, and the decision on how to block out those zones. And like any map created by a human being, you can squabble over where the lines exactly are. But we have 2 degrees of altitude from North to South Jersey. It affects a little bit. We have altitude from sea level to 1,803 feet. that has some impact. Surface conditions, I already showed you that with the last slide with snow cover, but I'll show you one more on that. And then land-water contrast, so huge. We haven't gotten below about upper 50s to 60 degrees along the coast so far this fall. Yet up in Walpack, one of our weather stations, see if I can get it right up here, hit 32 degrees at 5:35 a.m. on this past Monday morning. Mind you, last Friday it was in 90, 91 at a half dozen of our stations, and Monday morning it was 32. What was that about squeeze play and variability? So land and water contrast are huge. Last fall, we had our first freeze, I think it was about October 7th or 10th at a few stations in the state. Our station at Atlantic City Marina didn't fall below freezing until January 3rd. It's not uncommon to have a 100-day difference between the end of the growing season in parts of New Jersey and coastal areas. So, neat state, isn't it? Here's you can see the asphalt, you can see the rooftops and such. And those hold the heat. They gather the heat more effectively during the day from the sun, and they hold it in the evening. And here's an example of that. The image on your right is population density, and the red is obviously higher density areas. On the left is a map of temperatures at 10 p.m. on July 25th, of 2012. And the areas that are the darker orange are warmer. It's still near 80 degrees in those locations, and it's already into the low 60s in some of the rural locations. They're holding the heat. And notice how closely the maps compare with one another. So you can just look at what the thermometer is showing you, and I'll tell you what the population density is. Or flip her around. Surface type has a big impact on climate. And Sustainable Jersey, which I'm involved with, has an effort going, a subgroup of our climate group I sit on in Sustainable Jersey, is looking at heat island effects and how communities can evaluate their local heat island effects and be ready to take action in helping people health-wise when it comes to hot situations, particularly these urban areas that just don't cool off at night during hot spells. We're a precipitation-rich state. Kind of got a hint of that today. Every month of the year averages 3 to 4.5 inches of rain on average over the long term, with, shock, July and August being the two wettest months of the year. But evaporation almost doubles the rain in those months. So you don't play in the mud in the summer. You play in the mud in the winter when we only get 3.5 inches of rain or melted snow equivalent. But evaporation is nil. But the good news here is when we have drought conditions, there's a potential of snapping out of that drought in any month of the year. If you're out on the West Coast, you're in a drought in April, you're still going to be in a drought come November. There's no way you're going to escape it. You only have about a 4 or 5 month window. Here in New Jersey, we can jump out of drought at any time. Of course, we can slip into it at any time as well, although usually much more rapidly, obviously, in the summer when you have high evaporation rates, high temperatures, and water consumption is huge because everyone wants to water there. Sometimes we have too much water falling from the skies. This is a flood in March 2011. Biggest flood of the year in 2011? Irene came in August. But still, people forget, we had the Passaic River flooding in March of that year. However, sometimes we have too little. This is 14 years ago. This is Spruce Run Reservoir at very low capacity, and notice the month. Reservoirs fill during the winter, except when it doesn't precipitate much during the winter. This was really worrisome. This was the last drought emergency the state had with water restrictions, and I was down at DEP every other week, sitting on the Drought Commission just to evaluating what was going on, providing input for decision makers in what they were going to do in terms of managing New Jersey's water supplies. We've been very fortunate. It's been 14 years since we've had our official drought warning or emergency. We're not overdue. I hate that word. Climatologists hate that word. It's just where we've been the last 14 years. We've been close a few times, and yeah, we're a little close right now. It's very fortunate it's October tomorrow and not June 1st tomorrow, where we'd be a lot more concerned. But we don't want to see our reservoirs like this in March of 2017. Not that we can do a lot about it, Mother Nature speaking, but we can do something, and I know many of your programs must be involved with water conservation and education of the public and how best to use as little water as possible and still lead a comfortable existence. All right, let's look at climate change here. Got to cut right to the chase. Right to the chase. This is not a credo. I haven't taken a pledge. There isn't a secret handshake or whatever. But this is kind of what the Intergovernmental Panel on Climate Change has come. And they've had 5 reports. Full disclosure, my snow work is part of all these reports. It's been featured in a couple of them. But this is a group of scientists from around the world whose input into the science is put into one volume, but the executive summary is vetted by governments. They squabble over every word. So if anything, it's a conservative document. But believe me, you can't even put a dozen scientists in a room and get a degree on anything, let alone hundreds. But there are, at least in specifics, but this is by far the consensus view. The climate is changing. There's all sorts of evidence that the climate is changing. Step 1, that's only part of the story, because the minute you hear the climate's changing, what's the next question? Why? Why is it changing? And the evidence is mounted and mounted over recent decades that humans are having a major impact on the changes that have been experienced globally in recent decades. The word preponderance is there. We're scientists. That's where we get in trouble in any debate, because the minute you start talking about confidence limits and uncertainty, people's eyes roll. And if anything, I'm the conservative storyteller. There are environmental activists out there, perhaps in this room or whatever, who tell a compelling story. We know there are people who don't believe the story as much as they might. There might be ways of working with those individuals to do something about it, even though their beliefs aren't as strong. But I'm here as a scientist, as a boring professor, to just provide the background information to help you make decisions on what's going on out there. But I'm not going to shy away from telling you where I think, I feel, and what the consensus is. And we have theory, we have observations, and we have models. And at least the last 2 have imperfections, or at least are incomplete. But you put it all together, it tells a very compelling story of what's happening on Earth today, globally and here in New Jersey, and why it's happening. But first off, I've already talked about the volcanic impacts that can occur for multiple years, but there are changes that have occurred over tens of thousands of years to our climate that we can attribute to the way the Earth orbits around the sun and how its axis changes. It's called Milankovitch orbital characteristics that have been a pacemaker of going out of glacials and interglacials over the last couple million years on Earth, which is actually a very unique time in the billions of years that Earth has been in existence. And those actions, our orbital characteristics and the way our continents are configured relative to our oceans, has led to advances of ice sheets down into northern New Jersey on multiple occasions in the last million years. The area in light blue was last visited 20,000 years ago. In dark blue, sometime within the last couple of 100,000 years, but not at the last glacial maximum, 20,000 years ago. And with all that ice water locked up on land as ice, you had to go out to the continental shelf, way out on the shelf, to the slope to get to sea, to get to the beach 20,000 years ago. And if you weren't under the ice, you were in a periglacial environment with permafrost and a very different vegetative landscape. Rivers were flowing differently. It's not as if we didn't warm up a little bit in the summer, but certainly not as much as today. And of course, once on top of an ice sheet, you were much cooler. High point was under 1,000 feet of ice just 20,000 years ago. So the climate does very naturally, but on time scales of thousands and tens of thousands of years. And what we're talking about with what humans are doing to the climate system is occurring in decades of time. So that's a really important consideration. So part one, theory, then we'll look at observations and modeling. The theory is this greenhouse effect. The idea that the sun only provides enough energy to heat the earth in the absence of an atmosphere to a goose egg. That's a goose egg Fahrenheit, 0 degrees Fahrenheit. That's what the temperature of the earth would be without an atmosphere. A natural atmosphere for the most part, made up of water vapor, carbon dioxide, methane, and some other gases that we call greenhouse gases. These greenhouse gases can also be thought of as a blanket. When you're cold at night in bed, you put a blanket on you. And the heat from your body the loss of heat from your body or away from the neighborhood of your body is delayed by the blanket. Now eventually, you may not have thought about this before, the amount of heat you're producing is released to the top of the blanket, otherwise you're going to explode into flames during the night. But it will retain that warmth for some period of time. And if you're still cold, what do? You put another blanket on. And that serves as another layer to retain that heat a little bit longer. And that's what these greenhouse gases do. In very simple terms, they serve as a blanket that naturally warms up the earth to about an average temperature of 58 degrees Fahrenheit, averaged globally. So what we're doing with adding greenhouse gases to the atmosphere, carbon dioxide, which just on average went above 400 parts per million for the first time in probably maybe a couple million years. Just this year, it's been steady above 400 million parts per million, and it's never going to fall below it in any of our lifetimes or our children's lifetimes. So we've got these greenhouse gases, these trace gases, and they warm the atmosphere up, and that allows more water vapor to be held in the atmosphere. Because water vapor is the primary greenhouse gas. There's one piece of trivia to fool people. That was on yesterday's exam. What's the most prevalent greenhouse gas in the atmosphere? And it's water vapor. Now, we don't directly add much water vapor to the atmosphere or pull it away, but by warming the atmosphere with these increase of carbon dioxide and methane and unnatural chlorofluorocarbons, that permits the atmosphere to warm enough to hold more water vapor, and then you get a positive feedback and you're off to the races, so to speak. So that's what we're doing right now, is we've added a blanket that is warming the planet and is bound to warm the planet more in the years ahead. Not 58 degrees, so you still have a predominant natural greenhouse effect. We're just adding a thin blanket on top of the natural blanket. So there's room there to explain how things work naturally in the climate system and how we're just amplifying or augmenting what naturally occurs. This is theory. How you can add greenhouse gases to the atmosphere and not warm the planet almost implies you have to throw theory out the window. You have to throw proven science out the window. That leaves me shaking my head sometimes. Observations. The planet is warming. These are global land and surface temperatures, 1880 to 2015, and you can see that temperatures have really risen, particularly in recent decades. That's 2015 right there, folks. Guess where 2016 is going to be? It's going to be somewhere well above 2015. We are cooking in the last year or two, this planet. The last 13 months have all broken a record, going back to 1880, for the warmest month on record. So August warmth of this year broke the record for the previous August, 2015, and so on and so forth. And now that is in part due to what we're doing to the planet and the fact that we have a rather strong El Nino, a natural event in the tropical Pacific, which adds heat to the atmosphere. So that was a double whammy we've gotten the last year or two. And next year it's liable not to be quite as warm probably because we were not going to have an El Nino active. So there are natural forces acting here, but they're being dwarfed by the greenhouse warming that humans are producing. This is an interesting slide that's work that's being done cutting edge right now. And this shows you decade by decade that a lot of the heat that's being absorbed by the atmosphere is going into the water and being stored as energy in the water. Meaning that if we were to just shut off greenhouse gas production now, walk home, don't heat your house, cool your house, whatever, we've got heat stored in the ocean that will continue heating the atmosphere, even in the absence of us adding more gases to the atmosphere right now. And you can see it's not at the surface, but in recent years, we've found that it's down at depth. And this shows you a time series of, at different levels of the ocean, how the heat content has increased, particularly in the last couple of decades. There's a lot of heat being sequestered by the oceans right now, yet at the same time, the atmosphere is warming to unprecedented levels as well. And Jersey is joining in. We don't join in perfect in lockstep. The last 2 years haven't been as warm as the previous couple of years, but overall, and that's due to persistent weather patterns on local and regional levels. The East Coast had a couple cold winters because of the way the jet stream was, while the rest of the planet was warm. We were one of the cooler areas relative to the long-term average. Still warm average, but cooler compared to the rest of the world last couple of years. This year is a little different. I'm not so sure we're going to be 2012 as the warmest on record, but we may come in second. Of course, we have 3 months that are going to help, but still to come, that are going to help us determine that. So, the observations suggest that it is warming. But as important as that is to human health and all beyond that here directly in New Jersey and to the melting of ice and rising sea level globally, I think it's dwarfed by the concerns of what might happen to our fresh water. We can deal with temperatures a little warmer or colder, but we need to be able to access fresh water. And in New Jersey, at least, we've seen that precipitation has gone up a bit in recent decades. Maybe that explains why we haven't had a drought warning or emergency in the state since 2002. But you'll also note on this figure, you can see the year-to-year variations. And we've had more in the way of extremes. So don't always think about climate change as just, oh, something moving in some monotonic direction. Think about the variability of the climate and how that may impact your decision-making more than the longer-term trend. And it seems as if our climate is becoming more variable. These are the top 50 rainfall events in New Jersey by decade we've put together in our office. And you can see there weren't too many in 1992 to 2001. Of course, Floyd was one of those. But look at 2002 through Irene, through 2011. We haven't updated it since then. Look at the number of major top 50 rain events. And the interesting thing is, there are more in near the top 10 or 15 in recent decades. So, say the 70s had a lot of top 50 events, but they were modest, large events as opposed to these major ones we've seen in recent years. When it rains, it really rains. Okay, that's observations. I could go on and on and on, but we need to talk about modeling. These models are based on physical principles that are the same physical principles that go into weather forecasting. And don't sigh and say, oh, and they can't get the weather forecast right, so how are they going to get the climate outlook right? The fact is, weather forecasts are brilliant in this day and age. They're not perfect, but they're brilliant. A 3 to 5 day forecast today beats a 1 to 3 day forecast 20 years ago. A climate model of today beats a climate model of 15, 20 years ago. And of course, climate modeling only really began in the late 60s, right up the road at the Princeton Geophysical Fluid Dynamics Lab with NOAA and a few other locations. They continue to run one of the premier climate models in the world, along with a NASA group that I worked with at Columbia. Well, it's NASA Goddard Institute of Space Studies at adjacent to Columbia. So there's a lot of good climate modeling being done just in the New York metropolitan area. Again, they try to break down the Earth vertically, horizontally, land, ocean. They try to couple it together. They run it over long periods of time with the world's fastest computers. And they try to recreate what the past climate looked like. And if you can do that pretty well, then you can run it into the future and turn the dials, play God if you wish, and turn up the carbon dioxide and change the power of the sun and so on and so forth, and see what may look in the future. That's our crystal ball, as cloudy as it might be, into the future, are these climate models. So they are just part of this equation of theory, observations, and models. And here's one from an IPCC report earlier in this century. Good friend of mine, Jerry Meal from the National Center for Atmospheric Research ran this, and there have been multiple runs since that point, but this is kind of a bellwether figure here. There were models run to try to recreate the climate of the 20th century. First, they were run with volcanic variations. You can even see how it was cooler. That's Pinatubo's cooling that was modeled. That's the blue line with some variation, some variance around that line. Solar changes, slight solar variations, volcanic activity, and that's what was predicted for the climate of the temperatures of the 20th century without human influences. Then they ran the same models with these natural variations, so you still see Pinatubo there, but they also threw in greenhouse gases, and they threw dust that sits in the atmosphere too that actually helps to modify some of the greenhouse warming. And they got this red line with its variance, and they diverge around the late 60s, in the 70s, let's say. And then what's the black line there? That's what's been observed. So you can make the case that before the 60s and 70s, you couldn't separate out natural variability from any anthropogenic human-induced variability. It was all still lost in the noise. But for the last 40 years or so, you cannot explain the rise in temperatures that have been observed by modeling it without greenhouse gases and other anthropogenic influences. Is this proof positive? No. Again, it's part of that preponderance of evidence. So we've seen the theory, the observations, and now the modeling. So what does it mean for us in the future? Gotta get to the future. We're running out of time. The train has left the station. We're going to keep getting warmer. I already said there's heat wrapped up in the oceans that we've put in there, artificially, if you will. We're not going to stop burning greenhouse gases. Let's get realistic here. I'll talk about things we can do to deal with this a little bit in a minute or two. But we're going to keep getting warmer. We don't know how much, and that's going to depend on how we curb greenhouse gases for the most part. The temperatures are going to rise in New Jersey a couple degrees by the middle of this century, maybe 6, 8 degrees or more Fahrenheit by the end of the century. There's still a range of variations. And if you don't think that's a lot, has September been warm this year? It's going to be our 4th or 5th warmest September since 1895. But it's not going to be as warm as last September. That's number 3. It's going to be about 5 degrees above normal. So to give you a little feel on that. The summer was just the 4th warmest summer on record, and it was about 2 degrees above normal. And it was a hot summer. So just to give you a little sense that 5 degrees, 6 degrees is a lot when averaged over an annual time frame. The model suggests precipitation to remain steady or increase in New Jersey, but, and there's always the but there, more variability is expected in the climate system, more extremes of storms, of droughts, of floods. And yeah, and heat. We can have it all here with the more amped up climate system. It's the climate system on steroids, if you will. And sea level is going to continue to rise. And we're really starting to hone in on some ideas on sea level rise. You're going to see fluctuations in estimates, but perhaps a foot higher by the middle of this century to add to the foot that it's risen since the early 20th century, and maybe 2 feet beyond that by the end of the century. So we could be up 3 feet by the end of the century. Again, doesn't seem like much, but do your geometry. If you have a beach like this and you raise sea level 3 feet, you've lost more than 3 feet of beach. That's for sure. This is from the National Climate Assessment of a couple of years ago. Anywhere in red, we have annual here and the 4 seasons here. Anywhere in red is projected to get warmer when comparing the middle of this century to the very end of the 20th century. Anything in blue is going to get cooler. And notice that our summers have the evidence of getting warmer than all the other seasons, but coast to coast, warmer. Precipitation, same idea, middle of this century versus the end of the 20th century. Areas in green, wetter, the reds, and the earth tones drier. And you may say, well, yeah, the desert southwest is dry. No, that means the dry area gets drier, and the summer monsoon in the southwest may fail. Around here, look at winter getting wetter, but look at summer. Hotter, drier summers, warmer, wetter winters. What about our reservoirs? Think back to Spruce Run there. Well, maybe we can fill it up by March, but I can tell you we've had full reservoirs on May 1st and been in drought watches and warnings by August 1st if you have a hot, dry summer. So we're going to have to think about that in terms of water conservation, not just the annual averages, but what's going on seasonally. I might also, recognize that this area is the grain belt, corn belt of the country. So let's go. Extremes. Anybody from Manville here? I visited Manville, the south end of town, living in the next town over, 4 times. Since '99, and stood on the railroad bridge and taken the same general picture. Looked at the gauge on the Millstone River just upstream of Blackwell's Mills, which has a record back to 1921. And Floyd, second highest crest in that almost 100-year record. Irene, number 1 crest. Now on the Raritan, just downstream of the Bound Brook gauge, Floyd just beat out Irene, but not on the Millstone. But then also look, 2007 flood, a nor'easter, number 3. Number 6 was the nor'easter of March 2010. And then number 7, I didn't have my camera out for that one, was May 1st of 2014. You probably don't even remember that flood hardly. Oh, ho hum. That was the 7th largest flood of the last century on the Millstone. So we've got 5 of the top 7 floods on the Millstone, going back to 1921, have all occurred since Floyd. Now, there's been some development in the Millstone Basin, a little bit more pavement, a few more rooftops, but what this is signifying is too much rain in too short a period of time. And we've seen that time and again in 04, 05, 06 on the Delaware, in 99, 7, 10, twice in 11 on the Raritan, also on the Passaic at times. So is this already the extremes we expect in climate change? Are we already seeing it? And this is when I pull out my boring climatologist hat and say, well, climatologists need to be patient. You can't just jump to conclusions with a decade's worth of record. But when you see these things recurring time and time again, and your 1 in 50-year event is happening 5 times in a decade, then you have to start thinking that something's changing, something's going on, and then try to attribute it to something. So that's what we're working on all the time. I know a question of everyone around the state, particularly those of you in coastal locations. What about major storms? What about this rogue Sandy storm coming again? we're going to see more storms. We're going to see more severe storms, and perhaps more than we've seen in the past, because the atmosphere is primed. There's more energy in the atmosphere. There's more moisture in the atmosphere. We still need to trigger, and we still need things to converge and come together. Hermine didn't quite work out. The convergence didn't occur quite as expected. Sandy sure did. When you had upper level trough like we have affecting us right now, join forces with a late season hurricane coming up the coast. That's actually what the forecast models look like next week. I'm not saying we're gonna have a Sandy next week. But yeah, I mean, and it's going to be October. Sandy being the end of October had a little more amplification of the trough that came in from the west, and it was colder, and 3 feet of snow fell in the mountains of West Virginia with Sandy. But there are certain parallels there. But we see them time and again, but they don't always happen because everything doesn't just work out right. But when things can work out right in this day and age, with more energy, more moisture, we've run models with Sandy. 2012, it was the warmest year on record. Oceans were warmer than average off the East Coast. The models have been run with the sea surface temperatures that were observed and then with normal sea surface temperatures. Sandy took the same path in both model results, but it was a weaker storm with average sea surface temperatures. The above average sea surface temperatures kept Sandy cranking longer as it came up the coast. Don't look at sea surface anomalies off the East Coast right now. They're above average. They're above average. So, sea level rise. Let's keep the happy news coming. Sea level rise. With a foot of sea level, there you can see a little bit on the left in light blue, would be permanently underwater. Permanently underwater. Not just during storms. With a 3-foot rise, which appears likely by the end of this century, you can see you've lost a good part of that barrier peninsula down there by Seaside Heights. And by chance, and I'm not saying it's going to happen, if sea level is to come up 6 feet by the end of the century, our barrier defenses are gone in New Jersey, essentially. Again, I don't mean to sound a loud alarm bell, but these are plausible climate scenarios with some probabilities ascribed to them. So, impacts, actions. Let me start on the home stretch here. You guys all know out there, you've seen things going on. I've talked to the health officials of communities around the state, and they've told me how the climate's changing. I haven't had to tell them. You've perhaps noted it. It's hard to do when you're just looking anecdotally at things. You need longer term records sometimes to confirm things, but you've gotten a sense, I think in many cases, that the climate is changing and affecting many different aspects of how we live, where we live. Is there something we should do about this? Our plan involves horses and men. That's my answer. No. That's not my answer. Number one, knowledge. I always thank the audience for showing up and listening to me blab on for a little while, because hopefully I've imparted a little more information that can help you be more informed citizens, more informed volunteers in your communities. Number two, mitigation. There are things we can do to slow the train. And as I'll say in my last slide, last point, you guys are involved. You guys are in the front lines of some of this. But, as I've been saying to my classes for 25 years, and it wasn't very popular back then, we're not going to mitigate ourselves out of this situation. We're going to have to learn to adapt. That's words out of vogue. I should probably change the slide, but I'm old and climatologists slow to move. Resilience is the word today, and I've even been told that's sort of falling out of favor for what I don't know. And you see resilience has been there in this slide. We're going to have to learn to be more resilient, to adapt along the coast, to adapt our water supplies, to adapt when it comes to episodes of severe summer heat, and so on and so forth. And I'm just talking at the Jersey level here, not globally, where the impoverished people of the world are going to get a double whammy. They're already being affected by global economy and global actions, and they're already impoverished. And some of them are in the most vulnerable areas to sea level rise and other climate change. I'm not saying we have it easy here in Jersey, but we're certainly more equipped to adapt and become more resilient. And then finally, leadership. And that's where you guys are right there at the front lines in your communities as environmental stewards, seeing that your communities are prepared, seeing that your communities have the knowledge of what's going on out there. So congratulations and thanks to all of you. Because we've got a dilemma. I think this one kind of best sums it up. It's one of my favorite slides if you want to talk about a dilemma. Depends if you've gone to contract yet or not. The irony of showing that today is my son is closing on a home right by Chesapeake Bay in Annapolis today. And of course, how many times I said, let's look at the maps, let's look at the flooding potential. Dad, we're high enough up, we're going to be fine. And we're convinced he is, but that's a dilemma. Whether you're talking about sea level rise in the Chesapeake, and he does work for the Chesapeake Bay Foundation, so he's cognizant about that, or you're just a homeowner in any community, US, New Jersey, or global. There's dilemmas, there's decisions. I show this to my students all the time and say, you better think about this when you're going out and starting to develop your career and your life and such. All right, if I may take 2 more seconds before our concluding slide to show you what we've got out there for you guys to use. This is our New Jersey Weather and Climate Network. Anybody ever been on the site? We have 65 automated weather stations around the state. We will have 66 as soon as we get the one in back by the solar farm here on campus, right here. It's in the works. We've got certain levels of approval. We're fighting through West Windsor Township's planning board or whatever. We've never had to get a building permit to put up one of our stations until this campus. So I'm not too thrilled with that. But, anyway, we have 65 of these. They report every 5 minutes. Temperature, precipitation, wind. You can go online. They're updated every 5 minutes. It's not every community, obviously, in the state, but literally from High Point Monument over to Hallward, down to West Cape May, we've got stations up the coast. 91-mile-an-hour wind gusts recorded during Sandy at our station in Seaside Heights. Although the anemometer right there, they fixed the roof this summer and they screwed up our station. We're working on that. Liberty Science Center, we have one in Liberty State Park, all over the state. You name it, it's in every county, except we don't have one in Union County. Maybe it's from Union County. And they report conditions every 5 minutes. Terrific asset. The Weather Service uses it. National Weather Service uses it for forecast models, emergency management, so many things. So please use this. And if you happen to be interested in talking to us about putting a station in your community and you have good clearance and maybe some funding, we'd love to work with it. We're just finishing. This one here is part of 9 stations we're putting up between Mercer County and Cumberland County with money that came from FEMA with the train derailment in Paulsboro several years ago that put up a toxic cloud, and they want to be able to monitor the dispersion of any toxic cloud that might happen in the future. And they knew we had this weather network, and they said, can we supplement it by adding stations in Southwest Jersey? And we've done so with 2 of the 9 still to go in. So that's our network. That's what a station, one of our better, our top-notch station looks like out in Hunterdon County. And we even measure soil temperature and soil moisture at some of these stations. We communicate by cellular modem. They operate on solar power, and so on and so forth. So if you've got a hankering for a weather station in your community or know someone who might be able to help facilitate it, we do need open ground. We can't stick them in a grove of trees because you lose the wind information. It just doesn't help. But I'd love to talk to anyone who would be interested.
How much?
How much? Well, that station, today, and only today, basically, if you build a full-blown station and we put it in on the cheap, you can buy the equipment for $8,000 to $10,000, and we'll put it in for a couple $1,000. And we'll help maintain it if you help us get the resources to keep these things maintained, which is the hardest thing to do. It's the most difficult thing to do.
What's maintenance cost?
$8,000 to $10,000. We like to see about $3,000 to $4,000 a year to help with maintenance. That includes on-site. You know, if a data logger goes, that's $1,500. We haven't had any go. And the communications, I have a $1,000 a month phone bill with Verizon Wireless. And the office, I have two full-time IT guys that keep the database humming and keep the web pages going. So there's a lot of behind-the-scene costs to keep it going. But we really, I'll be honest with you, we keep this network going on a couple $100,000 a year. And there are networks like in Oklahoma that get a couple $1 million in state funding to keep theirs going, and they have 120 stations. And we have half that number, and we do it on about 20% of those funds. And none of them directly from state appropriations. So we're out there, and it's working. And truth, in Sandy, we had 54 stations up by that point. Only 9 didn't have solar power and failed briefly. Communications stayed up, and we lost 1 wind gauge, 1 anemometer. It's the only piece of equipment we lost during the storm. Weather Underground are kind of backyard stations. They provide some good influence, but they're not of the quality of these stations. Keep going here. These are the maps. You've already seen a map of these, so I can show you those stations. Each station has its own individual page where we put the name of the community and the sponsor on there. This is Snyder Research and Extension Farm for Rutgers out at Pittstown. And we use National Weather Service forecasts on those individual pages. So that's that. And then there's CocoRa's. Hands up for CocoRa's observers. Yes, love you all. I mean, it's great. This is the premier citizen science observing program nationally, I contend. With 15,000 volunteers. In New Jersey, we have about 250 volunteers that have purchased one of these $30, $35 rain gauges. It's a cheap hobby. And they mount it on a pole in an area that's not under a tree, not under a downspout. And they, once a day, maybe if it's extreme weather, they'll put in a special, but once a day they go out and they measure, and this amplifies the rain. That's an inch of rain, and it spills out of there into here if more than an inch falls, and they go and take their measurement, usually about 7, 8 o'clock in the morning, and they go online and they enter it in a database that goes to the National Center for Environmental Information, the old National Climatic Data Center. So it's part of the National Climate Database. Comes to us, we make fancy maps. We teach you how to measure snow. That's more difficult, believe it or not, than measuring rain. It's the only way we get hundreds of snowfall measurements after a storm. Our snow data is accessed 2 winters ago 40,000 times, resolving millions of dollars worth of snow plowing contracts, which you pay by inch increments. They use these observations. And anyway, this is a community collaborative rain, hail, and snow network, CocoRa's. This shows you the maps we make, and if you wonder why we need so many observers, we've got about 200 observations on this map. In addition to our automated ones, these are all by citizen scientists. Look at the variations in rainfall on this one particular day. It's the 31st of July into the 1st of August, and look at the pockets of heavy rain. But it didn't rain at all in the southwest part of the state. So rain does vary, and I just can't thank you, CocoRa's observers, and the people that go out every day. We have 100 people now who barely miss a day of the year. We have 250 people that if we get a heavy rain event, they remember to check their gauges. So to sum up, and I am summing up, as I said, moodiness or long-term climate personality, there's never a dull moment with the weather and climate in New Jersey, and elsewhere, of course. There's all sorts of evidence that the climate is changing. The oceans and continents are exhibiting climate change. We're primed for more change, more variability, more extremes. And finally, we got to keep an eye on things. Not just sit back passively and look, but learn more about things, and if necessary, work with people who can promote and facilitate action to make our world a better place. And before I say thank you, I do have all sorts of Coparaz brochures. Be happy to hand any out to you folks. And if you want more to bring back to your communities, we want 565 communities to have a rain gauge in it. So with that, Raritan Bay on a nice sunset. Thanks very much. Yeah, sure, absolutely. I'll be here through lunch.
Excellent.
And then I have to go.
Is this working? Yeah, there we go. Okay, so you're welcome to put those brochures on ANJEC's table as well, so people can come by them and check them out.
That's where they'll be.
We will take, you've got to turn that on, right? We'll take 2 questions because we're tight on time and we want to be respectful of everyone's time. So we have some board members. Nancy, there's a gentleman in the back, and then I'll handle the front here.
Here you are.
Yep.
You're on.
Hi, Brian Spiel, Councilman in Closter, New Jersey. Thank you for your time. Thanks for coming here. Thanks for talking to us. I see a lot of your models deal with surface reservoirs, surface rain, all that, and we have you're expecting some extreme fluctuation in that rain. Have you done any work into how that affects the groundwater? Because most of New Jersey either has a hybrid system or a groundwater-based system for a potable water source. Have you put any effort into looking into how that's going to affect that groundwater system?
Yeah, that's a great question, and the direct answer is no, I have not personally, but that's all, groundwater is all part of the equation. I mean, South Jersey, it's all the equation, because you don't have surface reservoirs south of Manasquan Reservoir. So you're pulling it out of the ground.